6.2, applying properties of rational exponents. We are going to do 6.2 today and tomorrow. Okay, I think you have a quiz on Thursday in here. I think it says Thursday. Yeah. Okay, so remember the properties of exponents. Remember, if you have the same base and you're multiplying them together, what happens to the exponents?
Stays the same.
No.
Oh, you add them.
You add them.
Like,
If I have the same base and I'm dividing, what do I do with exponents?
subtract.
If I have the same base, or if I have a power like, let's say I have 6 squared cubed, what do I do there?
Yeah.
Multiply them. Multiply them. Okay? Can I have negative exponents? No, so you have to put it into a fraction or put it on top, whichever is off. Okay. When we are doing this, we can also do this with rational exponents, with fractional exponents. Now, when you have fractions and you're adding them together, what has to be the same? The denominators. The denominators have to be the same, so you might have to do a little math to get them there.
Lord Jesus.
Okay? So if I have 5 to the 1/2 plus 5 to the 3 seconds, that means I have, or times 5 to the 3 seconds, that means I have 5 to the 1/2 plus 3 seconds. What's 1/2 plus 3 seconds?
2.
Well,
4 over 2.
it's 4 over 2,
So
which
it's
reduces to 2, so you get 5 squared, which is 25. Okay? You're going to take it as far as you can go. When it says simplify, it wants it simplified to the furthest thing. That means sometimes you're going to get a whole number as an answer, sometimes you're going to leave it in a fractional exponent. Okay? It just depends what happens. If I have 3 to the 5 seconds squared, what do I do? Multiply. So what is 5 seconds squared? It's 5, because you do 5 times 2, which is 10, 10 divided by 2, which is 5. So you would get 3 to the 5th, which is 243. Okay? And you're going to go on and on. Now, if you have numbers like, if I have a times b to the m power, okay? If I have 16 times 9 to the 5th power, that means I have 16 to the 5th times 9 to the 5th. I can break it apart and do things like that. I can break it apart with fractions and do it as well. So if I have 16 times 9 to the 1/2, I have 16 to the 1/2 times 9 to the 1/2. What is the square root of 16?
4.
4, which is 16 to a half. What is the square root of 9?
3.
So 4 times 3 is 12, and you can solve that way. Sometimes it's easier to break them apart, okay? If I have a large number, what?
Okay, so, never mind. I answered my own question.
Okay.
I just had to think of it.
So if like up top, let's say I have 20 to the half, and on bottom I have 5 to the 1/3. I'm gonna break that 20 into 4 to the 1/2 times 5 to the 1/2. Because now I can reduce those 5s. Do you get what I'm saying? I can do things that way. So I can separate or I can condense depending on what works for me. Okay? There we go. Okay. Let's evaluate all 4 of these. How do I evaluate 5 to the 1/3 times 7 to the 1/4 cubed? I'm simplifying it as far as I can go. What do I need to do?
You multiple.
I multiply what?
3 times 1, 1 times 3, and 1 times, oh wait, yeah.
Don't you have to distribute the 3?
Okay, you want to distribute that power, right?
That's what I
Yeah.
meant.
So you want to say 5 to the 1/3 times 3, and you want to say times 7 to the 1/4 times 3, right?
Yeah.
What is 5 to the 1/3 times 3?
1.
So I just get
5.
5. What is 7 to the 1/4 times 3?
3/4.
So I get 5 times 7 to the 3/4. Can I simplify that any further? Does 7 have a 4th root?
No.
So I can't go any further, this is where I'm gonna stop. That's my simplified expression, in this case. Okay? What do I do here? 2 to the 3/4 times 2 to the 1/2.
You got the same exponent, so you add them.
Well, I have the same base,
Yeah.
so I'm going to add them, okay?
So that's really 2/4. So
You wanna
get
change-
5/4.
Okay, so we're gonna change 1/2 to 2/4, good. And so then you get 2 to the 5/4.
And then that's really 1 1/4.
No, we want to leave it in improper fractions.
Yeah.
Do not change it, do not put it in decimals, understood?
Got it.
If we're dealing with exponents that are fractions, leave it. Because remember, I can change that into a radical. What radical does that look like?
4 radical 2.
A fourth root of
2/5.
2/5, to the fifth, okay? So remember, that changes back and forth like we learned in the lesson on Friday. So we need to be able to just leave it like that so that we can change it if we need to, okay? That's my simplified version. Now, what do I do here? 3 over 3 to the 1/4.
Oh, Jesus.
Oh, I don't know. And
Do you,
3 divided by 3?
Subtract because
You subtract because it's division. What power is with the 3?
1.
1. So I have 3 to the 1 minus 1/4. What is 1 minus 1/4?
Negative 3/4.
No,
I mean 3/4.
3/4.
Mama mia.
Okay, can I go any further?
Nah.
No, because there's not a fourth root of 3.
mm,
So that's my simplified version. Now, 20 to the 1/2 over 5 to the 1/2 cubed.
20 to the 1/2 times 3,
Okay, distribute that first.
and then 5 to the 1/2.
20 divided by 5 is 4.
20 to the 1/2 times 3 over 5 to the 1/2, right?
mm,
Times 3. What does the top become?
1 and 1/2.
No, do not put it into
Ah,
mixed
3
numbers.
over 2. Man, that is really hard.
And what does the bottom become?
5 and 3.
5 and 3 seconds. Now, I can still go further. What can I do?
20 divided by 5.
20 breaks down into 4 and 5, right? So I have 4 to the 3 seconds times 5 to the 3 seconds over 5 to the 3 seconds. What happens here?
Cancel out.
Yeah, those cancel because 3 seconds minus 3 seconds is 0. Anything to the 0 power is
0,
1.
1.
Anything
I have
to-
a
Why
question.
can't you just divide?
Yeah, that's what I was gonna say.
Will it
Technically,
not always work?
it won't always work. This might say 3 seconds, this might say 4 seconds, and then I'll have to subtract them.
Mm,
You get what I'm saying? So you would have 5 to 3 seconds minus 4 seconds. It just happens to be that this is exact same power. So in this case, I can cancel them. But you have to know in your mind, that means that I had subtracted them, it turned to 0, it turned to 1. Okay. So now I have 4 to the 3 seconds. Am I done?
Yes.
No. What does 3 seconds mean?
Radical 4.
It's
So
the
very-
square, yeah, the square root of 4 cubed. Does 4 have a square root?
2.
What?
2.
2. What's 2 cubed?
2 times 2 equals 4 times 2 equals 8.
That is your simplified form on this one.
Oh, but
Oh, Lord Jesus.
You have to be able to recognize that. So I always ask myself, remember the denominator is what root you're taking. So I always ask myself, does this have a fourth root of this number? Does it have a cube root of this number? Does it have a sixth root of this number? If the answer is yes, you keep going. If the answer is no, I stop with the fraction as the exponent. Okay? Yes. The answer is 8, because it's the square root of 4 cubed. Square root of 4 is 2, 2 cubed is 8. Okay? Okay. A mammal's surface area, S, in square centimeters, can be approximated by the model S equals Km to the 2/3, where M is the mass in grams of the mammal and K is the constant. The values of K for some mammals are shown below. Approximate the surface area of a rabbit that has a measure of 3.4 kilograms, which is 3.4 times 10 to the 3rd grams. How would I set that up?
I don't know, but I thought a monkey was smaller than a human and a horse.
Well, I would plug in stuff.
Okay, what would you plug in?
So I would take S equals, and then,
What's your K?
9.75.
Why do you say 9.75?
Because the K, it says the surface area for a rabbit.
For a rabbit?
Yeah.
Because it wants us to do rabbit, and rabbit is 9.75.
Yeah.
Okay, 9.75, good.
And then for M, I'll plug in 3.4 times
Do you plug in what?
3.4 times 10 to the
Yeah, I'm gonna plug in 3.4 times 10 to the third, because it wants in grams, and so it gave us the conversion over here, so we're gonna plug the conversion in. Good. 3.4 times 10 to the third, and then that's raised to the
To the
2/3. Okay, now, what do I do from there?
Okay, so you have to, do the exponent.
I do, I have to distribute that 2/3 into both segments.
Yeah.
So I'm gonna have 9.75, I'm gonna have 3.4 to the, that should go on the inside. I'm gonna have 3.4 to the 2/3, and then I'm gonna have times 10. What is 3 to the 2/3? 3 times 2 is?
6.
Divided by 3
Yes,
is?
2.
So here I have 100, okay? In your calculator, you're going to have to put it in this way to get your correct answer. You're gonna have to put in 3.4, the caret button, parentheses, 2/3, in order to get what that is,
Lord Jesus.
okay? If you don't put it in that way, it's not gonna read it right.
What is it called, the caret button?
Mm-hmm. So then you get like, I'm gonna round it to 2 decimal places, you get 2.26. And then here I have 9.75, so I'm gonna take 2.26, I'm gonna multiply it by 9.75, and then I'm gonna multiply that by 100. And you're gonna get 2204.6. What is this in?
Square, no. Surface area, so.
It is surface area.
Square
Something-
centimeters.
Square centimeters?
Yes.
Okay.
These things will need to go back.
Now, here's the deal. In the book, I believe it says the answer is 2,200, okay? So when you are doing this on your homework, you're gonna notice that your answer's off by a little, because it depends where we round at or how many times we round before we get our answer, okay? So if you're within like 2 or 3 either direction of whatever number they give you, you're on the right track, you're doing it fine, okay? If you're off by 100, you've done something wrong. Okay, just to figure that out. So know that there's a little wiggle room there. That's where we're stopping today.
Great.
Homework is on the board.
Can we go back to the last page? I think